Ladies and gentlemen, welcome to video number 24 in a series of video lectures that are companions to the book The Fivefold Sun, filed at the Bibliothèque Nationale de France in Paris in late 2017. We are today December the 8th in the year 2018, about a year later. Today we introduce the third sequence of solar oscillations for return period of more than 15 years. It is suggested to be the so-called irrational sequence of oscillations. We shall see now why it is called irrational. In this table are put together the 5 detected spectral peaks which are suggested to belong to one sequence, which is as shown in this table. You see that the base period, 30.1 year, is the same as in the poloidal sequence that was introduced in the previous video. Then there are two already well-known periodicities in solar physics, about 280 years, the Suisse-de Vries cycle, and the 2000 and about 300-year period, which is sometimes called the Hallstatt period. In addition, we detect two other spectral peaks at 132 years and one at 544 years. The entire span from the shortest to the longest period is about a factor 76. You see that here the growth factor, the factor between this period and this period, is about the same roughly as below between this period and this period. This is not the case for the other intervals. So why are there in this table empty slots? The empty slots serve to show how these periods might be interconnected. The postulate, the hypothesis, is that there are 5 interspersed peaks that are missing, shown by these arrows. And we shall now investigate what these peaks might be, which remain undetected and must be supposed to be unreal, not existent. We would have this peak, this peak, this peak, and these 2 peaks. What they tell us is that if we include such peaks, they are spaced at intervals which are separated by postulated factor 1.68, i.e. the mean and extreme ratio, at certain powers. Here, this interval of about 4.3, factor 4.3, is an exponent 3 for the mean and extreme ratio, as for this interval for which we saw in the previous page, we have a rather similar interval. However, between this period and this period, we have only, or this period, we have only intervals with exponent 1 or exponent 2 for the 1.618, etc. mean and extreme ratio. So in total, there would be 10 spectral positions, but only 5 are detected, and we have to assume that only 5 are real. Now, if we subtract these unreal, undetected peaks, we see that the irrational factor warrants its name insofar as it is based on powers of the mean and extreme ratio, which is in mathematics the most irrational number. There is a little bit more to this, this irrational factor, because the base period is idealized 30.3 years. This was discussed in the video in which we introduced the poloidal sequence, of which this detected period of 3.1 year plus or minus 1 year is also the base period. This amounts to an idealized value of exactly 411 rigid rotations of the Sun. And this is a number which belongs, an integer which belongs in a generalized Fibonacci sequence that was introduced in part 1 of the Fivefold Sun as a book and shown in video 5. The solar sequence, in which integers are separated by a factor 1.618, etc. And we see that by construction, because of this recursive rule in this sequence, the other detected periodicities in the sequence that we show today are also solar sequence numbers up to solar sequence number 21 for the periodicity of about 2,300 years, the length of which amounts to 31,241 rigid rotations of the Sun. So what we have is a set of solar sequence numbers. We saw in an earlier video that, in video 5, in fact, that in this solar sequence are found the integers which represent the differential rotation numbers in the kinematic of the Schwabe cycle. This was found and discussed in part 1 of the Fivefold Sun project as a book. And we find in the first integers of this sequence this number 411, which is the 12th solar sequence number and is the base, apparently, of both the poloidal sequence of the previous video and the irrational sequence in the current video. This table is drawn from part 1 and was shown in video 5. It shows that the solar sequence is the fourth generalized Fibonacci sequence based on the parameter of this integer following 1 each in the respective sequences, and in which in fact we have only here not 4 but 3 different sequences, because 2 are similar, 2 versions of the main Fibonacci sequence here and here. The intermediate one is the Lucas sequence. So we saw in an earlier video that the identified intracycle periodicities in solar oscillations, i.e. from the solar rotation up to the Schwabe cycle, represent Lucas numbers of rigid rotations of the Sun. Now we have solar sequence numbers of rigid rotations of the Sun for this postulated sequence of oscillations in the long term. This remains all very speculative. It looks nice and neat when it is shown in this way, but you will see now when we go through the individual detected periods that for some of them the evidence is faint. If this is all correct, among the 5 detected peaks, we would have a separation of the cube of the mean and extreme ratio 4.2, etc. between each of the detected peaks, except the peak at 208 years, the best known peak in solar oscillations beyond 100 years. These are the peaks that are equispaced in our detections. We will go now through each of the individual peaks. We bypass the base period of 30.1 year, plus or minus 1 year, because it was already introduced in video 23. Again, it is postulated to be the base of both the present sequence today and the poloidal sequence in video 23. So the next periodicity, which is detected 132 years plus or minus 4 years. You see there are 10 reports, and there is also 4 reports of a nearby trough at 126 years. So this period must be more than 126 years. What is its phenomenology? Tolini and collaborators in 1987 found this period in the aurora borealis, so maybe it is related to the auroral occurrence, as is the case for the base period of 30 years as an open field poloidal period. Idealized as an integer in the solar sequence with exact 1.618 factor for the separation between peaks, this length is 128.3 years. Now, the Suze-de Vries period, from the data under investigation in the meta-analysis for the Fivefold Sun project, we find 12 reports and no nearby trough for a value of about 208 years, which is right on the dot versus the usually given period in solar physics literature. This period was first mentioned as early as 1733 by Jean-Jacques de Méran, who wrote the first full treatise on the aurora borealis. He found this in the millennial record that he put together at that time. About 200 years he wrote. But the estimate of 200 years plus or minus 5 or 10 years was first proposed by these authors in 1960 based on the hard evidence of the radiocarbon record. You see now a table which allows us to assess the uncertainties and the reported values of this peak. We see that it rests almost only on radionuclide data, 10 reports versus just 1 report in the sunspot record, telescopic or not, and just 1 record in the auroral occurrence, at least in the publications that could be assembled for the meta-analysis in this work. In the radiocarbon record, we find a characteristic length of 208 years, and in the 5 other non-radiocarbon records, we find 207 years. So you see, when we do a mean of the 3 dataset means, we arrive at 208.2 years, which is almost identical to what is found from the radiocarbon record only. This is evident periodicity. However, it appears to be somewhat anomalous in the sense that it is again the only detected period in the set that we propose to put together in one sequence, which is not separated by a factor in which the exponent for 1618 is a multiple of 3. Evidence for the detected period also is anomalous in the sense that it is intermittent. Already Hans Suze, when he detected this period in 1980, found that it was absent in these 2 millennial intervals. So we have 2 scenarios, 2 lines of interpretation for these anomalous behavior. First of all, possibly the 208-year period is masked occasionally, for instance, perhaps in these intervals, by the very strong 88-year periodicity. Or the other scenario is more radical, puts in question whether this period is actually a solar cycle. It is an issue because it is a problem, because if this was not the case, then we lose the most cited long solar period after the Gleisberg cycle, which itself, as we saw earlier, as estimated by Rudolf Gleisberg, is not found in this work because it was an 80-year period instead of an 88-year period. So the reasons for the doubt for the 208-year period is that Zeus himself proposed that maybe an oceanic factor, the terrestrial ocean, was the modulating factor, not the sun. This remained an unsettled issue until Reisbeck and collaborators last year asserted that in their data such a period is not found in the southern hemisphere in their record of austral ice cores. So this would be only detected, according to this author, in the northern hemisphere of the Earth, which puts into question the solar origin of this periodicity. The matter remains unsettled. Then we move to the 544 periodicity. There is the weakest evidence for this period, only 8 peaks and 1 trough very nearby. Its phenomenology is unknown, but if we idealize it as a number of rigid rotations of the Sun, it is exactly at this value an integer of the solar sequence. Then we finally arrive at the longest period in this sequence, which is also the longest detected solar oscillation overall in this work, the about 2,275 year periodicity as detected in this meta-analysis, you see, from 13 reports. There is very strong evidence that this period exists. It was first detected by Jan Huttermans in 1971. 20 years later, it was proposed by other authors that this might be called the Hallstattzeit period. And in the 2000s, in this century, it is sometimes called the Hallstatt cycle for short. It could be as well the Huttermans cycle, after the man who discovered it. The Hallstattzeit is a German name for a prehistorical German period for which is hard to find any direct relation with the length of about 2,300 years. Usoskin et al. 2 years ago, recently though, estimated the epochs of the highs and lows of this cycle, and they found, if I'm not mistaken, I hope I repeat correctly what they found, the last low, i.e. a low in solar activity, a high in cosmic rays, took place about around 1510 AD, which is during a deep solar minimum. Idealized, the period has a length to be an integer of the solar sequence in terms of the numbers of rigid rotations of the Sun of 2,303 years, which is extremely close to the most often cited value in the literature of 2,300 years. We suggest to call it here a node because it is the single periodicity which is equispaced not only by 3 ranks, power 3 of the mean and extreme ratio, but also separated from the 208 years peak by factor exponent 5 for this mean and extreme ratio. So the repeat period for such a case is 3 times 5, 15 ranks, and the level of the power to be applied as an exponent to the mean and extreme ratio. By construction, this will not happen at any other position for return periods of more than 1 year and less than 1 million years. So this periodicity is very special. It's a unique periodicity in this particular suggested irrational sequence. This is the end of video 24 and of our discussion of this suggested irrational sequence of solar oscillations. In the next video, we will try to make a synthesis of long solar oscillations. I thank you so much for your attention.